Well, hi, good morning, and thanks so much for joining me here in my shop while I get a start on this beautiful looking radio. So this is the first video in a series. There's liable to be, I don't know, it could be 10 videos coming. I don't really know what lies ahead. I don't know too much about this radio. I really don't know anything about it, in fact. So since you may be a new viewer watching this video, I have to warn you a couple things. I don't edit these videos much at all. Just some transitions actually get edited. So sometimes I'm going to make mistakes, or I'm going to go off in the wrong direction, or I'm just going to go off in some crazy direction. And that's what's going to happen here. So I'm bound to say some things that aren't true and make some mistakes along the way as we sort out this radio. But I'm pretty sure, and it could be the case this radio is already operating. I'm not absolutely sure, but by the end of the video I expect this radio to be working quite well. So first step, the first video is all about inspection, looking it over, getting used to it, looking for anything odd or important that needs to be known, whatever that might be. So, okay, let's just take a look here at the back of it. SD Collins radio service. It says Kenwood 4546. So I'm going to guess where it says Kenwood 4546, that's a phone number. In Kenwood, you would take the first two letters, the K and the E, and and maybe the N, I'm not sure. But anyway, this would be a hint as to what the actual phone number is. So I used to live where I lived. My phone number was Logan 37653. That was my phone number. And the Logan, the LO, represented the first two numbers you dial. So that's probably what that is. Collins, I can't, no. This isn't the famous Mr. Collins, the famous radio engineer from so many years ago. One of the best, actually, without a doubt. It's got a sticker here that says Simpsons. This would be the retailer. Simpsons was a large general department store with stores across Canada. Long gone now, I'm pretty sure. Canadian Westinghouse Company Limited, made in Canada. Model number, can I get my flashlight to see it? Model number 512. Watts. 65 watts. That'll be important at some point. Doesn't say exactly where it was made. Just made in Canada. Probably made here in Ontario somewhere. Antenna connections. And that's about all. Now, just the general state of this radio is very, very clean. The deck here is very, very clean. Someone has been keeping it quite clean. Often I get these radios and there are just piles and piles of dust in them. This is a bit odd. What tube is this? This is a 5 something, so it's a rectifier tube. Might say 5Y4 on it. Okay, the rest of the tubes here are metal tubes. They're glass tubes with a metal covering on them, which shields them. Is very a big improvement in tubes. It's possible the original tubes were glass, just glass in here, but I don't think so, based on the length of this wire right here. The glass tube would be taller, and this isn't going to reach the top of it. So maybe it came with these. I don't know what year this would be. I'll take a guess. 47. That's my guess. 1947. But just a guess. We've got a couple of lights on the side. The precise positioning of these light bulbs is critical in making this panel look the way it's supposed to look. And at a glance, these bulbs aren't quite in position here. This one looks pretty close. And I'll explain that when I get down the road. All this black tape, the owner of the radio put in a Herculean effort to insulate these wires that run between the lights, because the wires are worn out. This must be the supply wires here. He's even taped them down to here. So we'll keep our eyes peeled for something going on here, like a short. but I'm bound to replace all that wire. Sorry, after all that work and all that tape. I mean, this is not not an easy thing to do. Put all this tape on here. Likewise, he's done something similar here with it. Probably not too helpful here because the wire is in clear space, and it wouldn't matter if it was bare there. So the radio comes with 3 large filter capacitors. These must be the filter capacitors, and this one on the top has some kind of deposit on it, as if fluid has come up from the inside and got out. Is that what happened there? Probably is what happened there, but will these all be shot? Well, we don't know. Let's take a look at the speaker here, because that's part of the picture. So the speaker has had one repair done here. Oh, it's had another one done here. It's not bad. I'm feeling for warps here. No, it's not bad. Looks like you can see some warping in here, but it's not bad at all. Probably sounds just fine. This is a Magnavox. Don't put your fingers through it, champ. The Magnavox just says Magnavox, and below it says the Magnavox Company, Fort Wayne, Indiana. And throughout the world, it says. How many ohms? No ohms. What model number? No model number. This is probably in good shape. It has its transformer here. It's not mounted in the radio. It's mounted on the speaker. And the wires are connecting here. So what I'm trying to spot is there a field coil inside here? You see these 2 heavy wires disappearing into here. If you look very carefully, you probably can't on the camera, I can see some wires coming out of the transformer and heading to voice coil connections up in here. So this almost certainly is not a permanent magnet speaker. It's an electromagnet speaker. The electromagnetic coil that's in there forms part of the power supply in the radio. Part of the filtering of the power supply, very important part of the filtering. These might be less important than that coil when it comes to filtering the audio. I'm sorry, the 60 cycle power coming in. So we're going to tip the radio up on its side. They've handily built this with this is where all the weight is in this power transformer, with it almost lined up perfectly with the edge here, which means I can tilt this thing and it should be rock solid. Okay, what's going on here? What's hanging out? So when the owner dropped this off, I discovered this right away. This is bad form here. Who did this? I want to talk to this guy. This is really terrible. This thing's just flopping around in here. There's another one up here. Look at this. Well, what's the guy thinking? These have got fluid or something coming out of them. This one anyway. This one too. I wonder if that indicates this thing's been sitting somewhere hot. But where would that be? In somebody's oven? This also means somebody been in here doing stuff. So we can't know. I can't know just sitting here what all has been done. The odd time I get a radio and somebody has done something tricky inside it. Look at the wires here. Look at the wires. See this wire up here? Can you see it's all cracked? There's a crack right where my finger's pointing there. It's all cracked along here. Bend this wire any amount, the insulation is going to shatter off of it, and you have a bare wire here. If there's one like that, there's going to be more like that. Sure enough. Let me get the close-up camera going here so we can get a better look. And yeah, let me also fix the focus on it. It's set. Just bear with me a moment here. What I'm doing is I'm calling up the dialog box for that camera, and I'm going to take it. I'm going to force its focus to. Come on. Whoops. Oops. Well, this normally takes only 9 seconds. It's going to take 14 this time. About like that. Okay, here we go. Let's start with that wire I was just talking about. I can see how cracked it is. It's cracked right through. So this is something to be, good to become aware of this right at the start. Now look at this capacitor. It looks like it found it on the side of a road and stuck it in here. Here's some more. Now, capacitors can look terrible and look really good, and often it really doesn't relate to their actual condition. But generally speaking, the worse it looks, the worse it is. There are a lot of bad-looking capacitors here. These all look like they're electrolytic here. Lots of them. Lots and lots of them. We got this thing here. Why is there stuff coming out of everything in this radio? What's that say? Cool ohm. Who came up with that name? 10-watt resistor. Looks good. Let me go to the other camera because we should still be looking at this in the long view for now. There. Okay. So quite large. That's a large control. It feels like this could be a wire wound control here. And what is it controlling? Offhand, I don't know. Probably volume, but this one down here could be volume. This has got the on-off switch on it. Back here. This has a tab sticking out the side. It's not being used. The wires look a little sloppy in here. The actual connection wires are hidden down in behind. I was going to say this looks like this might have been replaced because it has this tab. It's not being used. Why would they install? Why would they call for a volume control with a tap on it, but then not use it? Because this isn't the original volume control. I don't know that to be the case. Just making observations here. There's another what looks like electrolytic capacitor here. So we've got a series of adjustments. That looks like a dog hair there. Series of adjustments here, probably done from the top. Can we see that? Yeah, done up on the top, all right across here. One of them's pulled way high. Now again, that doesn't really mean anything in itself. Has these fantastic coils. To a large degree, these radios are these coils. I don't mean the coils are, the most important part. I mean, they're obviously they're an important part. Every part's important, but engineering these coils is designing them, engineering them, building them is part of the uniqueness of each radio. I can put it that way. You won't find these exact coils in any other radio. They're been built specifically for this based on the design of the design engineer. So that's why I look at these things. They are fantastic. Let's just look with the other camera because these are beauties. These are beauties. So, starting with a coil here, the winding design is done very much on purpose. It's tall and skinny for a reason. You see the wires appear to be on a bit of an angle. They're not just like this coil, they're just wound straight. But this one, they're wound on a bit of an angle. This is a very, very clever way of winding a coil. I believe it's to reduce the inter-wire capacitance, but I'm not sure on that, so don't quote me, but that's not by accident. It looks like that. Right above it's a tiny coil. See how the wire drifts from one coil to the one above? So this small separation is not an accident by any means. This is a carefully planned out, chosen thing, maybe controlling the bandwidth that's associated with this coil. Here's a different coil here. See the diameter of the wire is different. There's another a lower coil, upper coil with a wire in between. The engineer who designed this must have liked this technique, or he discovered something about it. Notice too, the wires on the coil, they're not in contact. They're actually spaced a little bit. And these ones, they look like they're right in contact. Of course, these are coated with varnish, and they're insulated. So they're also not in contact, and they're spaced by the width of the varnish, but it's pretty tiny. But these ones, look how carefully spaced all that is. Oh, there's the big mama wires here. So the ends of the wires plunge inside the coil tube, or coil form, and they run inside up to these terminals. See them popping out of these holes here, actually. Portholes. Got portholes up here, and the terminals are connected. There's no wires connected. No, but then the radio wires are connected up here. That way, the work on it, building the radio, soldering the wires on that, doesn't involve touching these coil wires. This whole coil is built, no doubt, on a coil building bench, I guess you would call it, and then provided to the builder of the radio. And you just grab this pre-assembled coil and solder it in on these terminals up here. Notice the terminals run right into the switch. This is all very clever design to minimize wires and stuff like that. So here's another whole coil. It's all very similar to the other one, but not identical by any means. One of these two coils, and it could even, I doubt it, I was going to say, it could even be mishmashed between them. I don't think so. One of these will be part of the circuit that controls the local oscillator frequency in the radio. And the other coil is probably having to do with the antenna or an intermediate stage in the radio. See, these wires come up and attach to these capacitors. These are capacitors, these tall things we were looking at earlier. Another piece of dog, it looks like dog hair. So all this stuff is very clever. See, there's a metal panel running down here, a metal plate separating the two coils so they can't see each other electrically. They don't even know they got a brother. They don't know. Unless they were told. That's that terminal that's not being used on the volume control. That's kind of suspicious. And these wires, they look a little tugged around. Of course, this is going to these capacitors installed here. Now, if you notice, this one, it's just taped. This is a taped connection. It's not on a terminal. It's just been taped up. Tape is holding on. Why would they tape it? Could be the other wire, the wire down here. It looks like there's two wires. One of them is running right into the transformer. The transformer is right around here, right here, but we can't see it. I'm looking for a hole where all the wires come out, but I think it, I don't know. It's just for some reason out of view. Here's a nice capacitor made by the Solar Manufacturing Corporation in Bayonne, New Jersey. Parts from all over the place, made in Italy. Yeah, but this isn't originally. See, this is one of the ones. Italy, though. Italy, really? You've got Italian radio parts. Italy has a huge history with radios, of course, because Mr. Marconi came from Italy, and there was a lot of science going on in Italy and engineering and that, and they were at the forefront. That's why there's a lot of Italian ham radio operators today. It's a legacy. So on the back of the radio here, we have this resistor here. This big long thing. Way up here. Wow, that's a long one, all right. With these attachments along the way. The terminals along the way. This is a big resistor I would guess it's a wire wound thing, but I don't know that for sure, but I believe it's wire wound. And they've mounted it right on the back of the chassis because this resistor is going to get hot and the heat's going to go into the back of the chassis here. So if you were to put your hand down here when the radio's operating, you no doubt feel warmth in it. Well, and there it goes. There it goes. Okay, so my last video I tried to explain this clock here, which you really can't even see it with the close-up camera, but that's my coffee break indicator. I don't know. Do I want to do a coffee break right now? Let's keep going on this. We'll just ignore that ringing. So here, fancy looking things there. Why all the fancy shape? Now this is the bottom of those tall capacitors. These tall guys. This is their bottom end. Oh, look at these wires. Oh boy, oh boy, oh boy. Oh my gosh. Oh no, don't touch anything. Oh boy. Oh, another one. Oh my gosh, they're all... Oh, look at the bare wire there. Ay. So a chance of a short circuit developing spontaneously in this radio because of insulation falling off the wires is very high. Very, very high. See that one? Red wire looks great. How come the one looks great? Because it's hooked up to this new old part that was stuck in here from Italy. Ducati. That's my Italian accent. Sorry about that. 14 microfarads. So what's going on here, I'm pretty sure, is someone has tried to augment the old capacitors by paralleling in additional capacitance. That's a typical repair method, nothing wrong with it. You leave the old ones connected. That could be what's wrong with doing that. In the short term, like when the radio was 30 years old, that's not a problem, but now it's 60 years old. These old capacitors could be very leaky. Now, just recently I was fixing an old radio like this, and for the first time one of these type of capacitors, big filter capacitors, was getting hot on its own. Oh, look at the wire down at the bottom there. Oh, which one? Any one of them. They're all wrecked. This is a very precarious machine to work on. And try to do one thing. Oh, they're all through here. All the yellow wires are shot. Phew. Now you want to look at this. Somebody's put a piece of tape here. It looks like. They tried to cover the exposed part of the wire with a piece of tape, which of course it's electrical tape. Electrical tape is crappy unless you can wind it and hear me now, owner of the radio. Unless you can stretch this tape when you're applying it, and stretch it a lot, like maybe 20-30% of its length, and then put it on stretched, it will come off like that. It will be loose like this, or it's just never going to work on something like this. You can't pull the tape hard enough to stretch it without wrecking the wires and all that stuff. So yeah, that's the whole thing about this electrical tape. You must stretch it when you apply it. Well, okay, there's an electrolytic capacitor here. Is it made in Italy? U.S. patent. Made in USA. More patents pending. Is that original? It's kind of buried under a few things. Well, it didn't come from Italy, so it could be original. Here's another high wattage resistor here. It looks good. High wattage resistors get warm. Oh, wait a minute. Oh, wait a minute. Let's just move this capacitor over there. Look at this wire here. See how this resistor is connected in series to this resistor. That's not original. They don't make connections and leave them floating like this. And they would use one properly sized resistor. So this and the two of them are not identical. They're two different resistors. This is a junk box repair. So somebody's rummaged around his junk box, found these two resistors he could put in series, and stuck them in the radio. Is it bad? Not necessarily. It could be they're properly sized and their wattage is fine and everything's good. It could be just fine. But it's another indication of somebody doing stuff. Somebody's done a fair bit of stuff to this radio. Now this is the one of those three capacitors. There's nothing connected to it. So he's cut away that one. And it's just sitting in the radio now. The next one is still connected. Easy thing to reach in there and cut the terminal. And this last one still connected also. But who knows the condition of made in Italy? When were you made in Italy? There won't be any dates on here and stuff. Not that we can decode. Often there's all kinds of manufacturing numbers on these things. Like that AIEC 2019.315 is probably manufacturing information. And I don't think it was made in 2019. I don't think so. He sent over special from Italy. Okay, can we go way down in this radio now? More of the cracked wires. So as cracked wires go, this is a very bad radio. Very few of them are this, that I've seen have been this bad. Often the radios have stiff wires, and the insulation is not cracked. But if you like these kind of wires here, these cloth-covered ones are actually very, very resilient. But these could be stiff like rock. And I'm going to gently test one of them here. Yeah, I can't really tell. You kind of got to put your fingers right on it. And just above it is a taped splice. Now, if you look at the tape, a little more light on it. You see that the tape has a rough surface, and the edge of it, the cut edge, it looks like cloth. So this would be friction tape, what we would call friction tape today. Friction tape, sometimes we call it hockey tape here in Canada. This is actually pretty good tape to use in a radio like this. This tape may have been put in decades ago, and it probably looks exactly the way it looks. Here's an even better example. Friction tape used here. Now, I mean, it's taking a beating here because this is where the speaker wire's coming out. It's just been, it gets bent in here. Look at this big blob here. Normally the speaker wire doesn't get worked, right? You put the radio in the cabinet and it just sits there, and this wire sits there and nothing moves. The power cord, on the other hand, is on the move. Something getting plugged in and unplugged. They've done the knot thing there. This certainly isn't the original power cord. Where's the other one? Where's the other wire? The other wire has disappeared under there somewhere. While we're looking at the power cord, let's look at the plug here. So these often break right at the plug, just like everything we have. And guess what? That's where you put your fingers. You put your fingers right here. Yeah, I don't want to get a zzz. Looks almost like copper sticking out there, but I don't think it is. I don't think there's anything wrong here. There's no sign of cracking on this. But it's not terribly flexible. Well, you know what? It's flexible like all these kinds of wires are. Not terribly flexible. Okay, what have we not looked at? What have we not looked at in here? Well, I got some nice yellow resistor here. I think this might be a capacitor, this one up here. And see lots of dog bone resistors in here, which is dating this earlier than what I said. Here's another floating connection here. I think that's a cold solder joint there. Hard to tell. Yeah, hard to be sure because everything is moving, but that has the look of a cold solder joint. Cold solder joint means the solder didn't flow right onto the wires properly. The wires never got hot enough. And it may look okay, but it may actually not be a very good electrical connection. And on this yeah, we looked at this one already. Well, okay, that's a headache. The wires in here are definitely a headache. Going to be a headache. Okay, so I like to look these things over pretty thoroughly, and I'm always interested in starting up a radio as soon as possible, including right when I get it. So in looking this radio over, it has a number of problems, like this kind of thing, but are they actually going to cause operational issues? Pull this guy right out here, man, because why didn't he cut back the black wire? He didn't shorten these wires up at all. He just put them in. I guess they're Italian wires. He wanted to maintain the Italian wires. I don't know. Do I dare turn this thing on? That's where my head's at. So to answer that question, I will stop, drink some coffee, and then come back and make a decision on whether to turn this guy on or not. I think I probably will. We'll see. Okay, so I've decided I'm going to take a vote on whether this radio should be turned on or not. I'm just watching those capacitors as I put it down. I think we're okay. Okay, voting is closing. I will now tally the votes. And the votes are in favor of trying to turn it on. Okay. That's great. I have to have the speaker plugged in because, as I mentioned before, the speaker the field coil actually is part of the power supply. Actually, there's a trick here. If you don't plug the speaker in, then you can energize a radio like this and there'll be no high voltage in it. You can kind of get the heaters going and get half the radio operating and see what happens before you plug in the speaker and then see what the whole thing does. If you wanted to, but I'm going for the whole enchilada at once. Now, before I do this, I wouldn't just plug that into a regular outlet. I'm plugging it into, again, this is because this is video number 1. You may have not watched any of my videos before. I'm going to plug it into this guy here. Really, I'm just plugging it into this extension cord. This white extension cord here. This gray plug is going to this meter here. It's just kind of it's not a very important meter, but that's what that is. If you notice the ground plug is exposed here, it's not going anywhere. So the ground terminal here is going nowhere. It's going into the ether. That's it. So this extension cord runs back to an isolation transformer. The isolation transformer removes the relationship between the 120 volt supply that's going to be in this extension cord and the earth I'm standing on, and the power system neutral, which is also connected to earth. Now that provides a very great level of safety doing that. I can't get a shock to ground off of stuff that's plugged into here. Not a serious shock. Maybe I could get a tiny little brush shock, maybe. The other thing is, okay, I'm going to want to control the amount of electricity coming over to the radio because I don't want too much coming over. So to do that, I run the electricity that's going to reach the radio through these light bulbs. They're in series with the radio. Some of the supply voltage, 120 volts, is going to drop across these bulbs. In fact, I'm going to screw this one. This is a fairly large radio in terms of the number of tubes. Not really, 5 tubes. It's really not that big a radio. But I do have both lights in. So this meter shows the line voltage it's supplied to my house right now. 115, 120, so it's 117 and a half. Not accurate. This meter, if you're going to see it go, this meter goes from 100 volts to 140 volts. Okay, it doesn't start at 0. So if the voltage is less than 100 volts, this meter will be sitting like you see it now. This guy here shows us either the line voltage coming in very accurately, it's 120 on here, or the voltage coming out of this. This is another isolation transformer. Yes, I have 2 of them in series. Stupid thing I've done, but I did that. So this guy has a dial on it. You know, I can turn the voltage up and down. Generally, I don't utilize this though very much. Occasionally I do. I like the dim lights. The dim lights. If everything is good, the lights are dim. If something is bad, the lights are bright. And they really are bright. They're going to hit me in the face. Trying to keep an eye on the meter here, that's a little tough. Those light bulbs that kind of come out and just slap me in the face if there's something happens while I'm operating this. Okay, now we need to practice a little bit. That's the on-off switch. Volume or tone. This one, volume or tone. This one. This is the one that feels like it's a wire wound resistor. Volume, tone. Wait a minute, there's 3. Well, you got me. This is the tuning. This is the fine tuning, coarse tuning. I'm not strong enough to turn it. Turn the fine tune though. It's slipping. Well, we'll get to that eventually. This would be the band switch, and I probably can't turn it without some help. This is a 3-band radio. 1, 2, 3 bands. The white band on the outside is the broadcast band, and that's what I hope I've switched this to. I guess this metal plate with these indents on it on the other side, they must... I didn't think it's part of... I don't know. Well, never mind. That doesn't matter anyway. Okay. I think we're all set. We're plugged in here. Now my switch panel. There's another meter on it. So this is the turn it on, turn it off. And this is the direct the power through the lights or straight to the radio. So through the lights. Now if I flip this up, power's on. The radio switch is off. Let's try this out. Nothing should happen because the switch is off. 113 volts possible, or no load voltage if you like, but the power is going through those light bulbs. Well, there's no power, so the light bulbs are not lit. So now I'm going to turn off the power, turn on the radio. I'm doing it this way for 2 reasons. One, if I turn it on, I can turn it off real quick without having my hand right next to the radio, in case the whole thing just explodes like a nuclear bomb. Baby, you better get back. Actually, get back, and you better just get taller too. I think it might help. Okay, so if stuff comes flying at you, duck. You know, duck. Nothing's gonna happen here. Switch is on. If this is volume, it's down. If this is volume, it's down. If this is volume, it's down too. What do I expect to happen? Well, these lights, if they're good, these lights are going to come on. Probably won't see it on the dial face. And it's possible immediately we'll hear a strong hum come out of the speaker. That's an indication of something. Stop the test right away. If that doesn't happen, we'll give the radio time to warm up. When the power is going through the light bulbs, the voltage at the radio is very low, 80, 90 volts. It takes a long time for tubes to heat up. So that's what's going to happen. You're ready now. So you should turn it on. These lights, they should come on and then go down. That's the heaters heating up in the tubes. And then after the tube heaters heat up, the cathodes heat up, and the tubes begin to conduct, the radio will draw more power and the lights will come up. I only actually need one hand. Well, there's 2 lights over there. Okay, 2 hands. The lights will come up a little bit. That's what I would expect. And as they come up, sound comes out. provided I've got one of these volume controls turned up a bit. But let's do that. Every one of these up a little bit. I still don't know why there's 3 of them. Should I do a countdown? 3, 2, A. Okay, so the lights have come on. Dim bulbs are dim. They don't seem to be changing in brightness at all. Voltage is probably very low. 80. That's higher than I expected. 86 volts. This box here, you should buy one. Buy something like this. Run around your house, plug stuff in, and find out how much power things really use. This is great. This is a great thing. Well, we'll give it a bit of time here. It's not likely at 85 volts that we're going to hear stuff out of the speaker. So what I can do to raise the voltage is I can raise the supply voltage using this. So it's only 83 because a lot of volts are dropping on these lights. Let's go up a little higher. I think up around 90, a little over 90 maybe. And how much power is the radio drawing? 40 watts. Did I say? I saw what the power was. Was it 65? Okay. Well, it should be making sound now. Let me just prop up the speaker a little bit because it's laying completely flat. You'll be able to hear it very well. There we go. Well, I don't hear a thing, but let's turn up. Maybe this is the volume. That's probably tone. This is probably the volume. This is probably tone. This is probably the volume. Ooh, bingo. Ooh, baby. I thought this was a wire wound resistor because when I turn it I can feel stuff. Now I think it's just a really dirty control. So, cover your ears. We're in the full blast position now, pretty well. Okay, I hear, you know what? There's no antenna on this. No antenna. Oh, some of these radios go totally silent with no antenna. That could be the case with this one. So this is a lead to an outdoor antenna. But the fact is the switch is not thrown to turn this on. But still, it's a big hunk of wire. Let's see what we... First, do we get any sound coming from just touching the antenna? Yes, we do. That's a good sign. Nothing on the ground side. Let's clip this on. Now I'm on the broadcast band, and this is a terrible antenna for broadcast. This is going to come off here. See what we can do with that. I'm on the broadcast band. Oh, I gotta put some knobs on this for sure. Well, I'm not hearing a thing. Maybe we're not on the broadcast band. Maybe the switch is dirty. So this could get suddenly very, very loud. So rather than have that happen, it's loud for me too. Whoa, that's bad news, isn't it? We'll have to clean this. Okay, so what I'm hoping to hear are clicks and pops. Pretty quiet. Okay, this is the broadcast band now, turned this way. I recognize that interference. I recognize that. We're tuned at 65. There's a station down here at 590. There he is. Okay, is this tone? Seems like it. What's this? This is volume? What's this? This is noise. This shaft. Look at this. This shaft has notches in it. Ooh, she scared the heck out of myself here. Those are break-off notches. Can you see? It's broken off right here. This is a replacement volume control. It had a long shaft with break-off notches, and somebody broke it off to this length so it would match the others and stick out the front of the radio. This is the one that looked like it had been replaced. No, this is the great big one. This has been replaced. What? Why is it? Why we got two volume controls happening here? This could be tone. It could be bass and treble. Could be a treble and a bass control. Funny that they mounted this one out on front here, but this one they mounted just the normal way. But they brought a bracket out and mounted this whole control sticking out on the front. This costs money to do this. Why did they do this? Why do they want this out here? He asks wistfully. Okay, well, the good news is radio works. This proves an awful lot here. First of all, the tubes have to be working. These coils have to be good. The filtering capacitors must be good enough. Whatever was done in here is good enough to make it work. So it's basically a working radio. And maybe even, you could even say, surprisingly well, considering that. Just leave it at that. Okay, so a couple things we can do here. We give it the rubber mallet treatment. Seriously? Well, kind of jokingly. Looking to see if there's anything loose in here. Nothing doing it. Ooh. What did we hit there? So I just banged on the transformer here. We got to deal with this right off the bat. This banging, it could even be affecting this. But I don't know. This is way too heavy a tool to be doing this with. I'm kind of joking using this. I'll show you what I usually use. I go the other extreme. I usually use something like that has no mass. And you don't expect this to do anything. But no. And don't poke the stuff underneath because we know it's already loose. This radio came to life there at one point, didn't it? Didn't it seem to just like double up in voltage? Double up in sound. Okay, that's enough of this. We've done enough here. So that was with 91, 92 volts. Turn it off. Ooh, what's that? Oh, you know what that is? That's the pointer on this meter. Bang! It's kind of like a built-in sound indicator that cranked this way high. I was compensating for the voltage drop on the dim bulbs here by cranking up the supply voltage. That's what I was doing. Okay. I'm not going to do any work on this radio today. I'm going to spend the day thinking a little bit about it, how I want to approach this. Those cracked wires are a very, very serious problem for someone who's going to work on a radio like this. Almost certainly that's what happened to these wires up here. They're all cracked to crap. And the fact is, if these were to have shorted, like this was worth doing. There's just other solutions that could have been done. If these wires short, you wouldn't even know it necessarily. The lights wouldn't come on. You'd think the lights are burned out. And meanwhile, there's a short on the power transformer. and it wouldn't take too long for this thing to overheat, and the next thing you know, blow this up, blow up the whole radio. That's kind of the way it goes. So, good first shot. I'll plug this before I forget. Turn the power off to it also. Duh. Very good. So tomorrow we'll start doing work on here. And I don't know. Let's look at it again. I got to come up with a little bit of some notion here of what I'm going to do on the radio. I think going after the filter, power supply filter right away is pretty high on the list. Get these guys out of here. It's 14. These are small. These are small capacitors. Actually, both are 14. Clean up the power supply. Figure out what to do about these ones, if anything. I think that's probably step one. Get the power supply cleaned up so we know that it's safe and secure. We don't have floppy stuff going on. These are like metal cans flopping around in the back of the radio. They aren't even covered and insulated. You know, like this has a cardboard cover on it. Wow. Wow, that's bad. Okay, for now that'll be my plan tomorrow. Power supply, and we'll kind of go from there. Yeah. Okay, well, thanks a lot for watching. Hope you found that interesting. And I think we're on our way to having a nicely operating radio here. See ya.